In chemistry, the amount of product that we obtain from a chemical reaction is known as the yield, and this yield can be measured either in grams or in moles depending on the context or requirement of the question or experiment. However, to be more specific and scientifically accurate, we distinguish between two different types of yield. The first is the actual yield, which describes the amount of product that we actually obtain when we carry out the reaction in a real-life situation, including any practical losses or inefficiencies. The second is the theoretical yield, which is the amount of product that we would expect to obtain based purely on a balanced chemical equation and assuming that everything goes perfectly without any side reactions or losses. For example, imagine we reacted 2 grams of hydrogen with 16 grams of oxygen based on the balanced chemical equation for the reaction between hydrogen and oxygen to form water. We would expect to get 18 grams of water as our product. This expected result is our theoretical yield because 2 plus 16 equals 18. However, in an actual laboratory setting or industrial process, things may not go exactly as planned, and in practice we might end up obtaining only 15 grams of water. In this case, that would be referred to as our actual yield. There are several reasons why we might not achieve a 100% yield, or in other words, why our actual yield is less than our theoretical yield, and although many factors could be responsible, there are 3 especially common reasons that you need to be aware of for your exams or understanding. The first reason is that not all of the reactants may completely react. Sometimes reactions are slow or may stop before all the reactants have been used up. Alternatively, if the reaction is reversible, it might reach equilibrium, where both reactants and products exist in a balance, and the forward and reverse reactions occur at the same rate. A good example of this is the reaction between nitrogen and hydrogen to form ammonia. In this case, because the reaction is reversible, some of the ammonia that forms will start to break back down into nitrogen and hydrogen again, so we never get all of it as product. The second reason is the occurrence of side reactions, which happen when reactants react to produce products other than the one we are aiming for. For example, using the same reaction of nitrogen and hydrogen to produce ammonia, some of the nitrogen might react with oxygen from the air instead and form nitrogen dioxide rather than the desired ammonia, reducing the overall yield. The third and simpler reason is that we may lose some of the product during the actual process, especially during handling and separation steps. For instance, if the product is a gas, it may escape from the container before it can be collected, or if we are separating a mixture by filtration, some of the product might remain stuck in the test tube, on the filter paper, or on the solid being separated. For example, when using a funnel and filter paper to separate a solid from a liquid, it is difficult to collect every last drop of the liquid. Some of it might remain in the funnel in the test tube or be absorbed by the paper. Similarly, if we are collecting a solid, we might not scrape off every particle from the filter paper, and some product would be left behind, reducing the amount we collect. Now, to express how much product we actually obtained as a percentage of what we expected, we calculate the percentage yield. The formula for this is very simple. We take the actual yield, divide it by the theoretical yield, and then multiply the result by 100. This gives us a percentage which ranges from 0% if we obtained none of the expected product to 100% if we obtained all of it exactly as predicted. For example, going back to our earlier example, where we reacted 2 grams of hydrogen with 16 grams of oxygen, the theoretical yield of water was 18 grams, and let us say that our actual yield was 15 grams. To calculate the percentage yield, we divide 15 by 18 and then multiply by 100. This calculation gives us approximately 83.3%. This means that we obtained 83.3% of the product we were expecting based on our theoretical calculations, and the remaining 16.7% was lost due to one or more of the reasons discussed earlier.